Hot chocolate, Azure Cosmos, Dapper. Entity Framework, Power Tools, Technology Suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Brice Lambson.
Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Hi everyone, welcome back again. We are here. Oh, Georgian's not there yet. Maybe they'll join us in a minute. After a good start, as always, professional and polished. So we're here again with another .NET Data Community Stand-Up, and we're happy to welcome Eric Sink to the show, along with Brice from the .NET Data Access team, and myself and Georgian as per usual. And the reason Eric is here today is we're going to talk all about SQL Lite and .NET, and Eric is the creator of the PCL.raw SQL Lite packages that we use and a lot of .NET infrastructure uses to bring in those SQLite binaries. Before we do that, let's, as we normally do, let's do a state of the unicorn. Look at what's going on in the world, at least in our little world, anyway. Okay, so newly merged for EF8, we've got raw SQL queries for unmapped types. So this is equivalent to doing from SQL, but now you can do it without that type being in the model, and that works also for stored procedures, querying from stored procedures, return types from views, functions, or just normal types that don't represent anything particularly. We also now have date-only and time-only support for SQL Server. So Eric EJ, one of our friends of the show, as we like to say, added support in Microsoft.Data.Sqlite client, and that meant we were also able to add it in SQL in the EF provider for SQL Server. So that now brings that up to par with what we've had for SQLite and MySQL and Postgres for a while now. So that's good to see. So you can use all this stuff now with the daily builds. Go, check out the link here, aka MS EF Daily Builds, to find out how to do it. It's pretty simple. And we have a lot of existing stuff that we've already talked about that's coming out in EF8 that's already in those daily builds. We've also now got what's new in EF8 with runnable samples, just like we've had for 5, 6, 7 versions. So in here we've got stuff like enhancements already that have been made to the JSON column support. We've got the raw SQL queries, so there's examples of how you can do that. We've got some stuff about the lazy loading, and it's not pushed live yet, but we have the stuff for date only and time only in ready to go in a PR. So go check that out. See how it works, whether you like it, if there's things wrong with it, and so on and so forth. Keep up with EF8. We've got the plan, aka MS EF8 plan, and then every 2 weeks we send a news update on what we've done, and there's also progress and stuff in there. So that's where everything is. And now let's talk about SQLite. So the plan for this show is to really kind of start at the bottom, so start at the low level and then work our way up. And so we're going to start off talking about getting the SQLite native binaries. I guess we should talk a little bit about what SQLite actually is and how it differs from other databases first. So and then we'll talk about how you get the SQLite binaries onto your system and use them in that low level way, and that's Eric stuff. And then we'll look at the AGO.NET provider we have, Microsoft.Data.Sqlite, which Brice created, and then we'll go higher up the stack and look at things that can build on the AGO.NET provider. Brice, you want to give us a quick intro as to what SQLite is and how it differs from other databases? And Eric, feel free to chip in anytime.
Yeah, so SQLite is an in-process database. So with a traditional database, you have a database server, right? And you connect to it either with like a named pipe or over the network. That's not SQLite. SQLite is just code running inside your application. And this is great for embedded devices or on your mobile phone. So you can have a full database engine with full SQL capabilities, all the optimizations of indexing, all the goodness of that just running in your process. And another cool thing is that the database is just a file on disk. So it's completely portable. You can copy and paste that to another machine, connect to it with another version of SQLite. So it's very portable, very, very mobile like that. And it's very powerful too. It supports pretty much the full spec, well, almost the full spec of SQL. It has really great features like full text search. I saw tweets recently like, why bother spinning up an entire Elasticsearch thing when you can just do SQLite with full text search and get kind of the same fuzzy matching and good like semantic tokens and stuff like that. There's a spatial add-in for it. So if you're doing a bunch of GIS data, geographic data, you can do some really complex queries over that data with the SpatialLite extension on top of SQLite. There's full JSON support. There's encryption. So it's a very capable database engine, and it runs pretty much anywhere, as I'm sure we'll see.
Yeah. So, I mean, the SQLite is basically on pretty much everything you use. Like if you've got a mobile phone, it's almost certainly installed on the mobile phone somewhere. It's on Windows, it's in Linux distributions. It's pretty much everywhere. It's a pretty universal system for doing kind of a lightweight SQL. But that means that there's different versions of it lying around, different builds of it, and also it means that you need to bring along or find somewhere a native binary which contains that SQLite code. And there's different ways of doing that. As I mentioned, there's the SQLite is often installed on a system with your operating system. but you might not want to use that. You might want to bring your own version with you, or you might want to have one with extensions plugged in, all these kinds of things. And Eric, you created some NuGet packages that allow us to do that in .NET and easily get the binary and use the binaries that we want to use. Is that right?
That's right. I originally created what I call SQLitePCL.raw, which I'm fond of saying is the worst named NuGet package anywhere. But I originally created it because I wanted just the very lowest layer. I didn't want to get in the business at all of trying to help people figure out the best way to interact with SQLite in C# and whether to use an ORM or whether or not, and all the different choices. I wanted to do just the lowest layer. And one of the unique things about SQLite is that unlike so many packages where the P invokes the interaction with the native code, and we should say SQLite is written in C, it's native code.
Yeah.
So often, packages just have the DLL imports, the P invokes as part of their overall high-level wrapper. But SQLite is a little bit unique in the fact that there are multiple versions of SQLite. There are multiple, you can get SQLite bundled, or you can get it from the OS. You can get it with or without encryption. There are compilation options. So many choices. And so I created this package just to say, maybe this is worth a package all its own just to deal with all that. And over time, what's happened is that quite a few other packages have built on top of it.
If you build it, they will come. I mean, I remember you said a lot of libraries kind of do their own P invokes. We did that for the first two versions of our ADO.NET provider. And just like you didn't want to get in the business of writing an ORM, I didn't want to get in the business of figuring out how to distribute this on all these different platforms and all the little nuances of invoking native code. I was surprised at the complexity of all that. So your package came along at like this opportune moment. We latched onto it. A few other projects kind of took it under its wing. Like we all kind of agree, like, yes, this is the best one out there for accessing the native stuff.
Absolutely. Should we have a quick look? Do you want to demo some of it for us, Eric?
Sure. I thought I would just go to a brief demo of this lowest layer. And well, actually, I should say if we were doing the very lowest layer, I would do this in C. But instead, just a look at what SQLitePCL.raw itself is like and why hardly anyone but Brice uses it directly, because SQLite's API is not friendly, and SQLitePCL.raw, my package, has made no effort to make it friendlier. So what I'm going to do here, I'm starting with an empty directory, and I'm just going to create a console app. I'm using old school command line tools and Vim as is my want.
That's awesome.
A bit old school here. So I'm going to create a console app, and then I'm going to mistype and add SQLite PCL. And the SQLite PCL.raw has a number of different packages. I'm adding one of the bundle packages that try and offer a batteries included kind of experience where everything is sort of configured for you. There are other packages you can use to have finer control. They're not widely used. So this one, Bundle SQLite 3, is a package that basically says, bring me the bundle and include SQLite itself, include SQLite builds. And there are other choices here, but I am fond when I do cross-platform projects of using the same compilation options for SQLite on all platforms, and so that's kind of what this is doing.
So you know exactly what you're getting here, right? You know the version you're getting. It's not dependent on Windows having this version and this Linux distribution having that version and Android having the other version or whatever, right? This is, you absolutely know what you're getting here.
That's right. And to make the other option, the other choice is a valid choice. There are people who prefer to say, I only want SQLite PCL to bring me a SQLite build for the platforms where I really need it, and on the other ones, I prefer to use the system SQLite. That's a valid choice too. It just is not my preference.
Yeah.
So I've created a project here, and then what I'm going to do is I'm just going to copy over the program file that I prepared in advance and then bring it up. This is a SQLite PCL program in its ugly glory. So, and I don't need to walk through every detail of this, but basically this opens a SQLite memory database, and it runs a query that basically multiplies two integers, and it prints out the answer. And as you can see, the SQLite core API, which this mirrors very, very closely, is an API where everything returns an integer return code. And so
this looks just like C code to me. Like,
well,
exactly. That's what I
check
was
the
thinking.
result of every method you call.
it basically is C code transliterated. And so after every statement, I'm checking the return code, and the part here that is not C is I'm just throwing an exception, and you can do what you want here, but this is how hostile SQLite development at the lowest layer is. And nonetheless, and I should show this at the top. There is there's an init call for my package that is necessary to be done at some point. EF Core does this for you, so most developers don't need to do this. But what I said earlier about the different configuration options, if you want to configure everything more manually, then there are ways to do that. But this is necessary to just say, for this package, just initialize it the way everyone uses it.
Mm-hmm.
So nonetheless, that's the program, and I still can't type, but you run the package, and it runs a quick query in SQLite, and lo and behold, SQLite can multiply integers for you. So
and get the correct answer as well.
Indeed.
Of course you do. That's good stuff. So you mentioned the bundle packages there, and I know there are several different kind of bundles, and I hear people talking about bundle green a lot. What are the bundles? Like, which one should I look for? What do I, what should I do kind of like by default, or
So I mean, what I usually tell people is, unless you have a reason, use bundle SQLite 3.
Right.
And
okay.
If you need encryption, I tell people you should probably go to Zetetic and pay them for their builds, and they work with me to basically support SQLite PCL, and so their packages integrate straight in.
Right.
If you don't want to go to Zetetic and pay them for their builds, you can use the builds that I maintain called Bundle eSQL Cipher, and
right.
These are builds of the SQL Cipher code from Zetetic, their community edition. I provide them because I started providing them and I haven't decided to stop.
Yeah.
But nonetheless, a lot of people use them successfully. They are almost certainly not as fast as the builds from Zetetic. There are compromises, and also, my ability to support them competently is non-existent. And then the other package that Arthur mentioned is called Bundle Green, and Bundle Green is basically when I first got started with this. Frank Kruger, who is very well known in the .NET community, he wanted a package that includes SQLite builds except on iOS, where he wanted to use the system SQLite. And so I created Bundle Green, and I called it Bundle Green because calling it Bundle Frank seemed rude without his permission.
Uh-huh.
And so Frank lives in the Seattle area. Every time I've been there, the whole place feels like a forest. It feels green. And so
Uh-huh. Uh-huh.
I created
And Seahawks, right, as well.
Bundle
So
Green.
yeah.
Yeah, there's that too. So nonetheless, people use Bundle Green, but that is its definition. It's Bundle
Yeah.
in SQLite 3, except on iOS.
Yeah, yeah.
That's really all.
That makes sense.
Do you know his motivation for doing that? Was that to kind of cut down on the app size,
Yes.
or okay?
That's my understanding. Yes.
So
And
I think that's
he writes his own kind of wrapper, SQLite-net. It's a
Yep.
little bit ORM-ish, and so yeah, I
Yeah.
believe it was app size.
Yeah, Frank is amazing. I love SQLite-net. If you're working on like Xamarin or Maui apps, it is tailor-made for like mobile devices. It gets you off the UI thread. It takes care of like, as you upgrade versions, like it'll kind of compensate for that and just kind of move your schema along as needed. It's really great for mobile devices. I love that library.
Frank does all kinds of smart things.
Yeah, he's brilliant.
We should have him on and demo some of that stuff. That'd be good. Didn't think about it for today, but anyway, I'm sure we've got enough for today anyway. So going back to I think one of the main reasons that I hear from people about why they want to use the version that's on the operating system is just keeping the size down that they have to install. But how big is SQLite? What are we talking about in terms of adding the DLL to your own package and bringing it yourself?
Well, that'll vary, of course, by platform. It's in the ballpark of a megabyte per DLL.
Right. So not that big, really, in the grand scheme of things.
It is nice that, I like to say SQLite has really outgrown its name, because when it started, it really was quite limited, and now it's just shockingly powerful. And yet it has maintained its fairly small size.
Exactly. It's pretty amazing all the functionality that Brice was going through, some of which is from additional extensions, but still all of the functionality that it has, just the SQL functionality that comes with it in the amount of size that it has is pretty impressive. And compared to installing Postgres or MySQL or any database system, it's just massively different. It's also very fast because it just goes through file access. So there's no it's running in process basically. So there's no inter-process communication. There's no pipes. There's no TCP/IP involved. And with modern machines with fast SSDs, it can be really, really fast. And then, as you were showing, Eric, there's an in-memory mode which doesn't even have file access, which is also fast. So it's very impressive what SQLite can do.
Couple points. One more reason you might want to use the system, the built-in operating system version, is then you kind of get the servicing agreement of like Canonical on Ubuntu or Microsoft ships a version of SQLite in Windows, and theoretically they would patch that if there's a security issue or something like that. That may be a reason, or like in a Docker container, if you just want to control the version of SQLite as part of your Docker composition, is another reason. And then on SQLite's capability, there was a few versions ago they enabled database files to be over 2 terabytes.
Yeah.
I can't imagine that much data, but they did that. Someone had a need for that, so it's pretty incredible.
Quick question here from our good friend Sebastian, who always likes to be a little bit snarky. Are you planning to rename them to be a little less daunting? I would imagine no, but I'm bringing it up since Seb asked.
Is that a question directed to me, I assume?
I think he's talking about the PCL.raw naming.
Oh, yes. No, I have no plans to be friendly.
I agree.
I think it's supposed to be daunting, right? Like,
absolutely.
Yes.
Absolutely. If I started making SQLite PCL.raw nice, then people beyond Brice would use it. And I can't have that. So.
Okay, so So how about we move on and look at some Microsoft.Data.Sqlite Lite. You want to talk about that a bit, Brice?
Sure. Let's talk to it a bit. Yeah, before we share my screen, there's nothing
Oh,
really interesting
okay.
on there
Then
yet.
I'll remove that for now. We'll bring it back later.
So yeah, so I created Microsoft.Data.Sqlite, and this is an ADO.NET provider. So if you've ever used like DB command, you know, data DB connection, those types of things, that's what this library is. And this started, funny enough, I was like a junior developer. I think it was like 2014, and we had this idea ahead of us, like we're going to rewrite Entity Framework, the old EF6, on top of this new thing that eventually became known as .NET Core. And as part of that, I decided, wow, I really need to learn ADO.NET. I barely know it, I hadn't worked with it a lot. So as this sort of weekend experiment, I decided to go and write an ADO.NET provider for SQLite. I don't know why, what madness compelled me to do this. But I did it, and I learned a ton about ADO.NET, and I learned even more about SQLite. It's kind of funny because you really got to put yourself back in that time. Like .NET Core was going to be the core, right? There was a meaning behind that name, and it was this lightweight thing. We were going to take out some of these APIs. Like when people think of ADO.NET, they might think of like the data table or the data set and the data adapter, data adapter.fill, like get the results and fill this weird table thing. And so we were going to strip all that out. We were going to make .NET Core this sort of lightweight, cut ties with all the legacy APIs. And so there was that motivator that goes into this. And then the other thing is we had just, we worked a lot with the official SQLite provider. We helped them port to Entity Framework 6, Entity Framework 5 and Entity Framework 6, actually. And so we were kind of familiar with that code. And I saw how dependent it was on those sort of legacy components. And so and then the other thing about .NET Core, there's lots of motivators coming into this project, was that it was going to be cross-platform. Before Entity Framework Core, our sort of like no-nonsense database, no setup, no maintenance, was SQL Server Compact. And it was great. It was lightweight. It just worked on files. You install Visual Studio and you just had this sort of file-based thing. And so we knew that wasn't going to go cross-platform. They weren't going to port that to Linux or Mac. And so SQLite sort of became like, okay, it's got to be SQLite because we want it to work on the server, on Linux and all that. We don't really want to we think it would be way more work to take the existing official system data SQLite package and port it to this super lightweight thing that's missing all these APIs. So let's take Brice's little weekend project and just start running with it. Let's see if we can build Entity Framework on top of it. And that's really where this project came from. Now, history is funny, and it by .NET Core 2, the strategy changed, right? We realized there's a whole bunch of .NET apps that we want to carry forward and just like bring them to .NET Core, get all the goodness of .NET Core. And so we started adding back these older APIs. And then lo and behold, by that time, System Data SQLite was able to just like work on .NET Core. So now we have two ADO.NET providers, and that's how we ended up in this place. But we'll look at some of the differences between those things. Let's actually go to the code now. So when working with SQLite so much, I came to know it very well, and it is a very quirky, very quirky database. I like to say it's like the JavaScript of databases. Like everyone's kind of encountered JavaScript at some point. And usually when they do, we pretend it's an object-oriented language. We treat it just like an object-oriented language, and we write all this code, and we pretend like there's an integer and a floating point type. And then we realize, we run into these weird cases where it's like, whoa, what's going on here? I can add members at runtime. I can delete members from types. Like integers and floating points are all just some weird numeric type. It's kind of like this facade. We like to pretend that it's like that. And I've come to realize that SQLite is a lot like that. So let's dig into some code and kind of look at some of those weird quirks. So this is standard ADO.NET code. You create a DB connection, in this case, a SQLite connection. And again,
so this is before we jump into this. So this is using Eric's SQLite Raw PCL.raw packages underneath, right?
Yeah.
But you didn't have to do anything for that, right? You just included the Microsoft entity framework called SQLite, and then that brought along the SQLite package that Eric was using earlier by default. Is that right?
Yeah, by default, this package depends on that bundle SQLite. And if you want to depend on a different one, you can depend on core and then install another package reference to like another bundle. So like, SQLite, shouldn't type live, but PCL.raw.bundle _ green,
Right.
if you wanted to use that version.
Right.
That's the wrong
So,
version,
but
you get
for
the
most
idea.
people, just go with the default thing. It's going to, it's going to be what you want for most cases. Only if you actually want something specific from, you either want the encrypted version or you want to use something where you're using the one on the operating system. Change that. Otherwise, just go with what we do by default, and everything should work.
Yeah, and I completely agree with Eric. Like most people will want that bundle one. That's the one that kind of gives you unity across all these different platforms. You get the full text search stuff built in, all the JSON functions and all that. You don't have to worry about, well, this system version does this and that one doesn't have this version of that. You get a unified one across everything, and it really creates a much better experience.
Yeah.
So
All right,
yeah.
good stuff. Sorry for interruption. Just wanted to
Connect
that together there.
Yep. So using this package directly, it looks a lot like the low-level code. You create a connection object, you create a command, and then here I'm going to create a table, and it has a single column, and the type of that column is banana. And I'm doing this to make a point. SQLite doesn't really care about type names. It's all part of this facade, right? When you use JavaScript, you pretend it's object-oriented. When you use SQLite, you pretend it's like any other database. So I'm going to create a column called banana, and this is where it gets a little weird. SQLite has a dynamic type system. You can put any type in any row of a column. So here I'm going to insert into my table, and I'm going to insert a string. I'm going to insert an integer. I'm going to insert a floating point value. I could also insert a blob, all into this banana column. And then I'm going to select the value from that column, and then I'm going to select the type of that column. And then this is just a simple thing to go through each field and print out each one with a tab and a new line. So let's run this and see all the quirkiness of SQLite. So in this one column, this one banana column here, I have a string of type text. I have an integer of type 42. I have a floating point of type real, all within one column. No other database will do this unless you use like a SQL variant type. And you have to explicitly make this decision.
And you're not recommending that people do go and use SQL variant, by the way.
No, there's almost no case ever to use that. there may be, but it's very uncommon. All right, so, and just to further illustrate the insanity of this, let's do a banana with, let's say it's a max bunch size, a bunch of bananas. Now 7 bunches of more bananas. I don't know what this means. Neither does SQLite. Let's run it again. And we get the same result. We should get the same result. If it works. I don't know why it's not working. There it goes. Same result. It doesn't care. You can get even more absurd and say, well, let's do bananas with a scale of 18 and a precision of 2.
Yeah.
I have no idea. I hope you're getting my point here. SQLite
it doesn't matter.
doesn't really care. Types are meaningless. You can pretend it's like JavaScript. You can pretend that's an integer type all you want until you start getting decimals coming back. I say it doesn't matter, but it actually does matter in some cases. So let me illustrate that.
Could I interject just briefly?
Sure.
Sorry to interrupt, but one or two things to point out here is that, and you may be going there, but SQLite actually does a fair imitation of being typed. Almost, it's pretty rare that anyone actually does what you just did in practice.
Absolutely.
Yeah.
They don't discover this ability of SQLite until they stumble across it accidentally.
Yeah, we're gonna see some of those cases.
Okay,
you
and
may think this is all absurd now, but I'll show you where it starts to really matter.
Very good, very good.
All right, so let's see. So I've told you that SQLite mostly ignores this type. It does actually use this type. So let's say this is a real column, a floating point column. I'm still going to insert a string, an integer, and a floating point. All right, so let's run this. Bring up screen. Sorry about that. All right, so here the integer is actually a real. It saw that it could do a lossless conversion into this real type, and it sort of unified onto real here. The text, this text test, it didn't know what to do with, so it just left it whatever you gave it to it as. All right, so as Eric pointed out, you may be saying, well, Brice, why am I going to insert strings and integers and floating points into the same column? And you're right, you're probably not going to do that. So let's look at the #1 case of bugs that I have seen with SQLite. Let's say this is a string column, all right? And I'm gonna insert strings here, all right? I'm gonna insert a string 42, I'm gonna insert a string 3.14. This looks completely sane, right? I should end up with a column with only strings, test 42 and 3.14, right? Makes complete sense. Absolute sense. You can pretend JavaScript is object-oriented all you want.
I assume it's not going to do that, given the way you're setting this up.
All right. Any bets? What do you think is going to happen, Arthur?
The 42 is going to be an integer. 3.14 is going to be a real.
Nailed it.
But you've told me this stuff before, so I'm cheating.
So string is really funny. It doesn't match their little rules of when it tries to unify on a type. If this was text, it would be absolutely what we expected. String is one of those, like, seems reasonable, but it falls outside their little rules. And so what it does, it treats this as a number, and it says, I'm going to try and convert everything to a number, even though that doesn't logically make any sense to you as a user. And so it says, oh, this string can be converted losslessly to a number. This string can be converted losslessly to a real. And so you end up with these different types, and this can mess up your collation. This can mess up joins. It can really.
I mean, isn't that a really culture sensitive thing as well? Like 3.14, that could be, culture sensitive, could it not? Maybe not. I don't know, but
yeah, coming in, it could be. So you have some with commas and some with dots, and then suddenly the ones with dots become integers, and the ones that don't aren't. Yeah, very strange stuff. All right, so that's sort of one quirkiness about SQLite that comes from its dynamic type systems. Let's look at its types a little bit closer here. I've mentioned these all, but let's look at them. At the end of the day, SQLite has 4 types. Well, technically 5. It has an integer type, a blob type, a text type, and a floating point type. Technically, null has its own type. So really, every nullable column has multiple types in it. We don't think about it that way. .NET obviously supports way more types. So what happens? We have to convert it down to one of those base types. If you put in a Boolean to Microsoft.Data.Sqlite, we'll have to eventually boil it down to an integer. It's either a 1 or a 0. And you can see, like, even dates, there's no primitive date time type. So we have to convert it down to a text using this format, which is actually a pretty decent format because it's sortable. If you sort a date time and sort this string, you'll get sort of the same behavior. So you don't really notice that too much.
Several comments already about date times and date time offsets, and this is some of the problems with dealing with those, is there isn't a date time type in the database, and so you have to do some kind of conversions, and the different conversions have different characteristics and properties of how they work. So there isn't like one right answer. But the string thing works pretty well for most stuff, right, Brice?
Yeah, definitely. Yeah, so let's observe this kind of this limitation that there are only 4 types in SQLite from a .NET perspective. So here I have a memory connection. I'm going to create a command, and I'm just going to select a parameter back out of it. I'm going to create that parameter, and I'm going to pass in a datetime.now. And then I'm going to execute the reader and get the value back out. And here we're going to print out the value and then the .NET type of that value. So let's run this. All right, so we're getting a string back, and it's in that format. And this is because you lose that type information when you try and round trip to the database, right? You have to get it into the database, and in order to do that, you have to convert it to a string. And when you come to read it out, you don't have any information other than there's a string in this column. And so this really becomes a responsibility of the application, right? Like, I put a datetime in there. I need to get a datetime coming back out of it. So if I do this, then that conversion will happen on the other end and we'll be able to round trip it. Oh, sorry about that. Yeah, so here I'm actually getting a datetime coming back.
And so that's taking the string value, knowing that it's expecting a date time, and passing it appropriately into a date time object.
Yeah, and you can use the generic
get fields, value.
Field value here too, which is better because not all of the types have one of those sort of built-in things. And so this is really the point where System.Data.Sqlite, that official SQLite ADO.NET provider, that has been around for ages. I think it was contributed by, I think his name was Robert Simpson, something like that. He wrote this way back in .NET 2 days, and this code has really thrived. It eventually got taken on to be like the official ADO.NET one. There's an ADO.NET version, ADO.NET provider in Mono that's based on this code, and it is super capable code. Any feature imaginable from ADO.NET, data tables, data adapters, all that, it works really well with. So if that's your goal, stick with the official System.Data.Sqlite. But here's where we sort of had a philosophical divergence. Because of this problem, they want ADO.NET to work, right? ADO.NET is sort of founded on this premise that everything is strong typed and columns only contain a single type. So what they did, if we look back at my dynamic type, this program, they added additional semantics to these column types. So if the column type is date or date time or timestamp or something like that, something that they conceived would be a date time, they will automatically get the date time back out. So if I had get field or get value here, like I had before, and this was coming from a column, then it would know to just, oh, okay, even though that type information has kind of been lost, we're going to use the column type, which is great when it comes to columns. But it creates a real big problem when you have something like this. There is no column here. And even though a date time went in, that information is still lost. So one of the ways that code solved this problem is they actually introduced an entirely new SQL statement. So you have to do like types and then like date, time, and then do the select clause. And it's not just for columns. Imagine you're concatenating first and last name. Suddenly that's not coming from a column anymore. So that one's probably pretty obvious because it's still a string value, but there's cases where you had to do this. And what this means is that in System.Data.Sqlite, they have to parse the SQL to find this type information. Then they send it to SQLite, which then again parses it to understand it. And so this is really, again, the philosophical difference between Microsoft.Data.Sqlite and System.Data.Sqlite.
So on Microsoft.Data.Sqlite, on your package, you're trying to stick very true to the nature of SQLite. So it's idiomatic of .NET in terms of using DB commands, DB connections, all of that kind of stuff. But you're not trying to layer anything else onto what SQLite itself does. Like the values work the same as SQLite. The type system works like SQL type does. The SQL doesn't need parsing because it's straight SQLite. Is that right?
Yeah. Yeah, so we wanted, like, again, the whole idea behind .NET Core is to be lightweight and fast. And if we would have had to start parsing SQL or doing anything else to compensate for this, like that kind of went against our goals.
Yeah.
So absolutely, we wanted to, whatever quirkiness SQLite had, we were just going to deal with it. We were just going to let it shine through, come through into ADO.NET. And this is why when you try and use Microsoft.Data.Sqlite with some of those other ADO.NET constructs, you run into really hard things. And basically you're sort of limited to those 4 types, 64-bit integers, 64-bit floating points, strings, and blobs.
Right.
And this is why today, if you try and reverse engineer a model from a database in Entity Framework Core, a SQLite database, you'll only end up with those 4 types in your model. And we're working to address this. We're kind of loosening our zealous view on all this.
I think there's an element of when you put EF Core on top of Microsoft.Data.Sqlite, then it starts being more reasonable to have some more semantics in there. But at the same time, the trade-off there is you also now start coupling your database to .NET in a way that is perhaps not great if you've got a SQLite database that is actually going to be used by different languages. Like, what does it mean to have a column name that's date time or something or date only or whatever, whatever it might be, that's a very specific kind of .NET type. You're really pushing that language down in that platform down into the database where it perhaps doesn't exist. But then, as Brice is saying, there's a pragmatic thing there where, well, maybe if you only ever use .NET, you don't care about that, and so if we have this information, it kind of makes sense to use it in some spaces. But definitely tensions there, I think.
Yeah. All right, so I'm staring at this code and I tell everyone all the time, never write this code. All right, we're dealing with connections, we're dealing with commands, we're dealing with parameters, we're dealing with readers.
ADO.NET, don't you love it?
No, I hate it. If you're writing this code, stop. You're wasting your time. At the very least, let's install something here. Oh, that went weird. Dapper, let's do it. Let's just do it.
All right, Dapper, right. So we're going a level up on the abstraction here now. So we're now using Dapper on top of Microsoft.Data.Sqlite.
That's right, which is on top of PCL.raw. So
absolutely,
we're going up the stack. We're going 1 level up.
Yep.
All right, so I don't want to do any of that stuff. I just want to come, I'm going to actually start way down here.
So just let me interject real quickly. There's a lot of questions coming by. I am marking them so that when we get a chance, we'll come back and answer some of your questions. But let's do the Dapper thing first, and then we'll bring some of them up and then see where we are.
Sure. All right. So Dapper is incredible. I love it. If I could write all the tests for Microsoft.Data.Sqlite using Dapper, I probably would. Because see all that code up above? Let's look at what it looks like in Dapper. Execute. Sorry. I need to use Dapper. Sorry. Using Dapper. Oh, it went away. Hang on. Did it restore my package? Oh, you know what? I installed it into the wrong one. I do that all the time. There we go. There we go. Look at all these extension methods right on my ADO.NET connection object. I'm going to execute a scalar, and I want to get a date time out of it. And the thing I want to execute is this stuff right here. And then I want to send it some parameters. This is one of the coolest things about Dapper. You can use an anonymous type, and just say, oh, geez, if I could spell it right. Datetime.now. So suddenly, all this ugly code, even the open actually, could just go away.
Wow.
And the reader. Boom. Dapper. Saves lines of code. Don't waste your time writing ADO.NET. All right, and if I run this again, obviously the same thing, just in way less code. Oh, and it comes up on the other screen every time. There we go. So I'm getting a date time back out.
Awesome.
Everything's beautiful in way less code. All right,
Yeah,
so let's answer some questions about the types, and then we'll
let's just talk about the Dapper thing, just to connect the dots there. So Dapper is a package that has been out there for a long time. It's often called a micro ORM, a micro ORM. It was created by Nick Craver and Mark Gravel at Stack Overflow, when there was a survey on Twitter a couple of weeks ago, what do you use? It was great to see people using EF Core. Dapper was up there as well, and then there's somebody was saying, oh, I just use ADO.NET, and I can understand why people might not want to use EF Core. It brings in a lot of stuff that maybe you don't want if you're trying to keep everything really lightweight and small. So I can understand the reasons why people say, oh, I don't want to use EF Core. I can't understand why anybody would write the ADO.NET code instead of Dapper. Like, there's no reason in my mind. So if you have a good reason why you would do that instead of using Dapper, then by all means let us know. Because to me, it's like there's no real good reason to be writing all that code instead of just using Dapper. And it's very minimal. What you're putting on top of it, it's not going to be any worse performing. It's there's really no reason to use that.
Yeah. Like, I agree, and I write an ADO.NET provider, right?
Yeah.
I write that code, and I'm telling you, no, use a higher level abstraction. It's not worth the time. It's not worth all that boilerplate code.
Okay. So let's look at some questions here. So I think we're gonna look at some EF Core stuff in a minute. But we have this question, SQLite doesn't care about column types, but they matter for entity framework. And to a certain degree, that is true, right, Brice?
The model types matter for entity framework. If your model has a datetime in it, entity framework core will read a datetime out of that column. And so, no, technically the column type,
that's
the only
right,
time we use the column type is during reverse engineering. And we're going to try and be smarter about that in EF8.
Yeah. So I think the fundamental thing here is that EF has more information about what you're doing than ADO.NET, the Microsoft.Data.Sqlite does. So because you've got a model that says this thing is a date time, then we know, even when we're creating a parameter, that it should correlate to a date time, and we should do the date time stuff. And so it can be actually a lot smarter about what's happening. But hopefully we'll look at that in a minute. Okay, so some of these are also EF Core stuff. Let's see. So here's a question. SQLite supports strict types too.
Yes.
You want to talk about that, Brice?
Yeah. So EF Core, we decided that we would only ever use the 4 primitive types: text, real, integer, and blob. And this really kind of got rid of all the insanity of dynamic types, right? Like, we only ever put those values in, and because those column types are the same, it won't ever try and coerce it into a different type. And so a few years after, SQLite introduced something called strict tables, and it's kind of the same concept. It restricts you to only using those 4 types in your database. So in the actual create table statement, if we go back here, let's actually just show this. So if I have create strict table, this would throw, it doesn't know what a string is. It would say, hey, you need to use one of the main types. Okay, text. And so it kind of adds stronger typings around those 4 basic types. Again, this is kind of what EF was already doing. They just added some syntactic sugar to kind of ensure that your table's doing that and not mixing types.
Which I would say, I think this is a really important feature for a lot of people. The strange type system of SQLite is a turnoff for some people. We've seen some of those remarks in the comments to the right, and I'm sympathetic to those remarks. I like strong typing in my programming languages. I like it in SQLite. Often when I use SQLite before strict tables, I created a set of triggers to enforce strict typing on my tables because I like strict typing. And so this feature takes away or it addresses a major criticism of SQLite that I think is important.
Yeah, I agree.
Do we have any plans to create strict tables if you use EF migrations to create the database?
So that's a tough question because that's basically what we're doing today. We're just not using the strict keyword. If we start adding the strict keyword, we break compatibility with older versions of SQLite. So it's like, is it worth doing? I don't know. I don't know the answer to that yet. So no, I don't think there's any plans to, but maybe if enough people ask for it and enough users are beyond that version of SQLite, then we could. But to me, it's not worth it at this point.
Does creating a using strict, does that stop you from SQLite from converting values? Like when you put in 42 there, will it always now keep that as a string?
I actually don't know the answer to that. Do you, Eric?
I don't know the answer to that.
Okay.
I suspect it does enforce it at that level. I
mean, that would be quite useful and another good reason to use it, right?
Yeah, because I think that's true because they introduced a new type, any, which says, yes, I intend to put variant types in here.
Right. Okay, so question about what happens if you do something that basically is invalid. So if I put an int column, but then I read it back out with, put text in an int column, but then I read it back out with get int 32, what happens?
SQLite will do its very best to give you text, and it will give you text back. If that string happens to start with a number, it will give you that number back. It's a little absurd. If it doesn't start with a number, it will give you an empty string back.
Okay.
So
because there's an assertion here that on System.Data SQLite it reads 0, which seems insane. But I don't know. Maybe that's only.
Oh no, that might be true. That might be what it does if there's nothing at the beginning of the string. So it'll see there. It'll see it's like there's nothing there, and I don't know. Try and do 0.
So nothing is the same as 0, right?
Yeah.
Or not. So we've got some questions here that are more about SQLite in general, and then some EF ones. So we'll look at some of those after. I just want to show this one comment. They would rather recreate Dapper from scratch rather than learning something new. Yes, I think we've all met some people like that. So that's just the way humans are, I think. Okay, shall we go on and look at some EF core stuff, Brice?
Yeah. I'm worried about time here, but I guess you guys always go over.
Oh, so. We always go over. We can do at least another 10-15 minutes.
All right, let's look at another really cool feature of SQLite. So here I'm using Dapper again. I have a connection. I'm creating a posts table. Posts have an ID, a date, and a title, and the ID is auto-generated effectively. Here I have some sample data here, some dates, some titles, and I'm inserting these all into the database. This is another cool thing about Dapper. It doesn't have to be an anonymous type. So here's a type with these things. These things come in as parameters. So that's super cool. And here I'm querying back all the posts and then just printing them out. And what I want to do here is I want to create a user-defined function. I only want the posts that were written on a leap year. So in any other database, you would have to write this function in some weird dialect of SQL, right? Postgres has PL SQL. Oracle also calls theirs PL SQL. Transact SQL for SQL Server. And you have to sort of write all this logic in this whole nother subset of the SQL language. Well, SQLite, they don't want to be in the business of inventing a language. Why would they, honestly? You're running in the process. Your application is already using a language. And so they had this clever idea of, we'll write the stored procedure in whatever language you're using. And so we've surfaced all that stuff in Microsoft.Data.Sqlite. And let's look at what that looks like here. So I'm just going to paste this in for the sake of time. So on the connection, we're going to create a function, is leap year. And I'm going to write it with this awesome modern lambda, right? We're going to take in a date time value, and we're going to return whether the year of that date falls on a leap year. So look, no SQL. I wrote all this in C#, and I have all the power of C# behind her. I could call a web service if I wanted to inside of a SQL function. Don't do that, by the way. That's a terrible idea. But you could, right? You have all the power of that. You have regular expressions. You can do it. You have if statements, which is cool. If statements are pretty powerful. And so now when I run
access another SQLite database inside the don't do that either.
You could use your DB connection here and do all kinds of weird stuff. So another really, really, really compelling thing here is that this is .NET code, right? So what if I put a breakpoint in here? What's going to happen? Let's run it and find out. So this is my code calling into, I guess we don't need to see the output. We're calling into execute query. It's passing that all the way down into SQLite. SQLite got handed a function pointer. It's calling back into my .NET code, and I can debug this right here, and I get full .NET debugging.
That's very cool.
Here. Oh, that's right. I went to the wrong stack frame. There we go. Now I can hover over it and see like this value is coming in. I can do whatever I want. And this is called per row in the database. Like this is the function calling into this. Really compelling, really cool way to write user-defined functions. I wish I could do that on SQL Server.
Well, as somebody commented here, it's just like SQL CLR, which it kind of is, but yeah.
Instead of the CLR running inside SQLite, SQLite's running inside, well, next to the CLR.
It looks like it if you squint, but it's really a different beast.
Yeah. So just to prove that this works. Oh, I hit the breakpoint again. Didn't I remove that? Keep going. Oh, now I lost the output window. There we go. So 2012, 2016, 2020, apparently those were all leap years. I don't know. I don't know the actual logic. I'm sure there's like all kinds of nuances in this code.
So while comments like SQLite doesn't support stored procedures, which technically is true, it has this capability, which in many ways is more powerful and more useful than stored procedures. I think this was actually in a discussion around testing where this is possibly not a great, if you're testing, you've got stored procedures, you probably don't want to be using SQLite, but in terms of functionality, this is pretty cool.
Mm-hmm. And it supports aggregate functions and all kinds of functions here. So I'm looking at this, and I really don't like writing SQL. Dapper's cool and all, but I don't hear anyone asking for, hey, add a SQL API to the generic lists and stuff. No, people don't want to write that. So let's convert this little app here into Entity Framework Core. So let's start by installing. I like how I have my E here. Let's fix that. Whoops, Microsoft. This is a mouthful here. Entity Framework. I can't tell you the number of times I've misspelled framework. So we're gonna. You know what I could have done? I could have just.
Brice back in the day many years ago was a strong advocate for these packages just being called EF Core. So he's going to try and get that in every time. Oh, yeah, I'm going to misspell Entity Framework.
I know. Look how much better it would have been. Just EF Core. That would have been cool. But anyway, so I'm just gonna cheat. I'm gonna change the ADO.NET provider from data to Entity Framework Core, and now I have Entity Framework core installed, which depends on the ADO.NET provider, which depends on SQLite PCL.raw. All right, so Entity Framework, we need to create DB context. I'm just going to call it my context. I'm not original. Figuring. Oh, here's another one where I just constantly gripe about this. Whoa, what did that do?
What, that it's called Options Builder?
This is called Options Builder. Me and Rowan, if you guys remember Rowan,
Yes.
great PM. He pushed for options, and I totally agree. So I always rename it to options.
Was I on the Options Builder side?
No, yeah, you guys were like, it's a builder. It has to be called builder.
Okay, I was probably wrong.
All right,
Naming things is so hard.
It is, yeah.
it is.
And when you join Microsoft, you just get worse at it. I don't know, like, it just happens. I don't know why.
Well, it's like, that question earlier about renaming my packages. It's like,
yeah.
I hate to be, I shouldn't maybe have been so snarky, but changing names is even harder. I hate changing names.
Yes, definitely. Once you've chosen it.
All right, so here's really post and then post. I can type. Oh my gosh. Remember that time I couldn't write a for loop? That was pretty sad. I went back and watched that. And I'm like, dude.
I don't even remember that.
Loop.
That's why you have an IDE with snippets that just,
It's true. It really helps. All right, so this is really all you need to get started, except we need a hook to be able to add our stored procedure here. There's lots of good ways to do this. I'm sure Arthur's going to cringe at the way I chose to do this, because there's interceptors in EF Core 8. You can actually tell it like own the lifetime of this connection. So I'm just going to add it to my DB constructs directly. I'm going to be a good citizen. I'm going to dispose of it when I'm done. And then I'm just going to copy this code up here. Oh, anyway, wherever it is, I'll just copy and paste it from over here. In here. So instead of passing a connection string, you can actually just pass the connection here. And this will tell it whenever Entity Framework goes to access the database, use this connection that I passed in. And this gives me cool things to like modify the connection to add these user-defined functions or do things like that. We'll also need to create our leap year function here. All right, so here we kind of have the same, there's kind of the same lambda we had above, except I'm going to make it an actual method on my DB context. And then I'm going to add this DB function attribute. And this tells Entity Framework, whenever you see a call to this in the link tree, translate it to a SQL function. And then SQLite's going to come in and say, well, the implementation of that SQLite function's right here. So it's a little confusing. So
the DB function is the same thing that you would use in any other database to say, I've got a function in my database, defined in my database, and when you execute that query, I want you to call that function. And so this just becomes a placeholder for writing your query in link. And it's essentially the same here, right, Brice? Except that in this case, you are actually providing the implementation of the function as well, because as we've just talked about, SQLite is just going to execute the C# code you have rather than having its own function defined in its own language, whatever, in the database.
Yeah, and keeping everything in one place really lets you kind of not think about how it's going to get executed, right? Is it going to be in a link tree? Am I just calling it from like client code, or is the database calling it? It all kind of leads to the same point here. All right, and I want to do one more thing here. I want to log the SQL here. Wow, that looks horrible. And this is just just console writing anytime the command executed event is fired by Entity Framework. All right, so let's go back, and we no longer need to do any of this. We just need a context. So I'm going to call it DB. Arthur hates it when I call it DB, by the way.
I'm fine with it.
He hates it. And instead of writing all this, we could use migrations. I don't think we're going to have time to go into that, but DB database ensure created, and this will ensure that the database has the schema for my type here down here. All right, so now I can get rid of all of this code. I don't need
I
any
will
of that.
say though that you really should be doing a using there for your context.
Thank you. That is actually, I agree. There we go. Now we won't leave anything dangling.
Yep.
Okay. Here we have our posts. We don't really need a for each over all this stuff. Oh, we already converted that stuff to Entity Framework. All right, so in Entity Framework, db.add range posts. I need a for each over it. And then save changes. All right, so we got rid of, so far we've gotten rid of our schema creation. We've gotten rid of all of our inserts.
So I
And
notice
now-
you're not using the async methods here.
That's true.
And you can use the async methods, but you're going to an in-process database, and that in-process database is not actually. No, I would. You don't have to. I'm not suggesting you do, because it's not actually going to be async, because SQLite itself does not have async methods for doing its data access. So. But
Yes.
it won't matter because there's no network round trip or anything like that. It's file access. It's fast. It's really not going to matter.
Yeah, that is another gotcha. The Microsoft.Data.Sqlite doesn't implement any async. So you can call the async methods. You'll get an extra state machine in memory maybe, but it will all execute synchronously. But you probably won't notice because it's fast enough. So
Yeah.
You don't have to use async. You probably don't want to, but if you do, it won't really matter.
Exactly.
All right, now for the last part is our query. db.posts. We do it in the old school syntax. I think Arthur hates that too.
I don't hate it. I just can't write it myself. I just write it in the other way and then tell ReSharper or Rider to switch it for me.
And here's where I use this db function, right? I want to tell it to call this function when it translates to SQL, and this is kind of the way I do that. So here I do db.is leap year, and then the post date column, and then select p. You know, one thing I love about Visual Basic, it doesn't require this. That might be the only thing I love about Visual Basic, but
I was gonna say it's yeah.
And XML literals are cool, but nobody uses XML anymore. So now, if it had JSON literals, I think it would be all the rage.
Exactly.
All right, so I got rid of my data, my schema, my DDL, my data definition language, my DML, my data manipulation language, and now my query language, all written in an Entity Framework.
So moment of truth, is all of this live coding going to actually run?
Let's see. And we're logging the stuff now, so
yeah,
we can see what all it's doing. Boom. All right, we got the same results.
Yay.
Let's go back up and look. Well, looky there. There's the create table post. I didn't have to write any of that. Thank you, Entity Framework. I guess I kind of did have to write that because I implement that, but you get the point. You get the point.
Yes.
Look, it even did better than me. It named my foreign key constraint and added these not nulls here.
Yep. And you got an auto increment key by default, which was nice.
Yep. I got all those inserts. Same kind of code. Oh, it did even something smarter. It did a returning clause. So after I inserted them, I can see the ID that was inserted. That's cool.
So it didn't batch this stuff?
We didn't bother with batching on SQLite.
Yeah.
Because it's in memory and you're not saving any network round trips.
Exactly.
And it also helps us validate the non-batching code path inside of it.
Yes.
So, and then here's that query. And it's calling that is leap year function. And I could put a breakpoint in there and it would go all the way through Entity Framework into SQL and back into there. So yeah. And I hope that this illustrates like kind of the progression of like all the way down to the native stuff, all those checking return types and all that stuff, to ADO.NET where you have to do these parameter objects and command objects and readers, to Dapper where you still have to write the SQL, to Entity Framework where just like we're really working up the stack here. And I love how this illustrates like the less you have to worry about the database, the more you just write your application code. Super cool.
Indeed, indeed. So there was a question earlier. I can't find it right now, so I apologize whoever asked this. Whether this function was available, this use of functions was available in EF as well, and Brice has demonstrated that it is. So good stuff. Okay, let's go. Let's finish by asking some of the questions that have kind of built up that weren't necessarily very specific or were more about EF. So this one from early on, which isn't really EF specific, although it mentions it in the question. The wall and shum files, as I call them. What's the deal with them? How can they not be there in ASP.NET Core or otherwise?
Yeah, so this actually relates to no async. Instead of having asynchronous APIs, SQLite recommends that you use this thing called WAL, and it stands for write ahead logging. And it makes writes a lot faster, or at least makes them less blocking. And so it completes faster, and you kind of get the benefits of async without the async stuff. Any database created by Entity Framework, so here I used ensure created. Any database that Entity Framework creates will turn that on by default. If you want to turn that off, pragma journal mode equals, I don't even know what the default is, but this is basically what it is. You can just open that database file, set the right journal mode, and it will no longer use those artifacts. But it will be slower.
I think we had a bug, and I don't remember what version it got fixed in, where we weren't necessarily cleaning these up. So it may be that if you're seeing these left around, it's just because you need to update to a version that is appropriately cleaning them up when the database goes away.
Yeah. And pooling made those stay around longer too. So you can clear the pool if you really need to get rid of those things during the process.
Good point. Good point. Okay. Where should we go here? Okay, let's talk a little. There's been several questions in the chat around using SQL Server or something else for production and SQLite for testing. And Shai isn't here. He would give you a lecture on it as always, but it's not a terrible thing to do. It's certainly not as bad as using the in-memory database that ships with EF. You really should never use that, because you are still using relational databases. But as we've seen with something like stored procedures and then some of the syntax things, if you're doing raw SQL, there are differences. There are things that are not supported. I mean, temporal tables in SQL Server is one that comes up often. Yeah, that doesn't exist in SQLite. It shouldn't exist in SQLite, in my opinion. It never will exist, hopefully. Use your production database system for testing, not your production data in your production database, but the same database system that you use, because and I'll say it again, we have 120,000 tests or whatever that run on EF and hit real databases, and on my laptop they're under 10 minutes to do all that. It's not slow if you do it right. Okay, here's an interesting one. Is there any preferred way to scale SQLite to multi-server, replication, geo-replication, or cluster? Either of you guys want to tackle that, or shall I talk?
There's been a lot of Twitter noise on like large scaling SQLite and using it kind of in the back end. I have no expertise on the matter, but there are people pushing for that. I would say you're probably using the wrong database if you need that kind of scale.
I would chime in and just say, if you had left out the word preferred, there are plenty of answers, because there are some really interesting things going on with people using SQLite as a storage engine and then layering replication, distribution, all kinds of things on top of that. Some of those are just awfully neato. I'll just say it that way. But has the world settled on one that everyone agrees is preferred? No, we're not there yet. But so, I mean, I wouldn't recommend one of them, but I do like looking at some of those things. They're interesting.
There's definitely interesting ideas going on there. At what point you lose the benefit of having SQLite as your database as opposed to something else? I don't know, but yeah, there's some interesting directions. Okay, we talked about testing. Oh, here's one somewhat, well, not really related, but one that comes up quite often. Concurrent access to a SQLite database. What's the deal there?
So one thing, concurrent access. There can only ever be one writer, obviously. But let's pretend I have an actual database here. Like, one thing you can do to really boost concurrency. So you have like an ASP.NET app and you want to really up your throughput. Probably the best thing you can do is use a shared cache. And this lets each connection kind of share more together, and they can collaborate better, and it's lighter weight, and it's less blocking, less locking, I guess I should say. And keep that write-ahead logging mode on. It will really increase your throughput. But yeah, Sebastian, who made the comment earlier, he runs Orchard Core on SQLite, and he has some amazing throughput. I'm shocked to see how performant Orchard Core can be on SQLite. So
that's good stuff. In terms of dangers there, so ADO.NET, as I'm sure everybody knows, is not thread safe. So DB connection and therefore SQLite connection is not thread safe. DB command, SQLite command are not thread safe. Is there issues at the SQLite level? Can you have multiple threads concurrently go into the SQLite database? That's okay?
Yeah, it's pretty good about blocking.
Okay.
Other processes and other threads.
So basically, it'll just block until one thread, the thread using
it's block heavy. SQL. That's kind of why I think a lot of people say don't use SQLite for a website. It locks a ton. But if you do some of these mitigations, it is actually really good about that.
Cool. So there was this question here. I think it actually got answered in the chat. They're creating the function specific to SQLite, or is it available for things like MySQL? So it's specific to SQLite, and this is because SQLite is running in your process. So you're not going through, you're not creating a TPC/IP connection and sending over a wire protocol on that. You're not creating a name pipe. You're not doing any shared memory or any of that stuff. You're just basically, it's running in your process that your application running, and that's what lets SQLite do this. Anything else, even SQL Server where it's got the CLR running inside the SQL engine or whatever, that's still not doing this because it's still going over into basically another process and doing its stuff in another process.
Yeah, if you look at what's happening here, is you're handing SQLite a name and effectively a function pointer. You can't pass a function pointer across a network stream. It wouldn't be able to call back into you. So this specifically is not possible with another one. You have to implement this using something the database understands, something the database can execute. It can't reach across the network and call back into your app. Thank goodness. But this aspect of it, yeah, this aspect of it right here, to say whenever you call this method inside of link, translate it to a SQL function, and really this might help it be a little more clear here. So whenever you see this method in link, call this function here, this SQL function.
So that's common, yeah. So a couple of comments from Seb Hurst. Apparently, I've been saying TPC/IP instead of TCP. It's because table per concrete type is just stuck in my head. And then also, apparently, Brice was talking about Orchard Core, and SQLite now is as fast as Postgres. So if Shane was here, we'd be up for some fisticuffs. But
that's right.
But not, so that's good. Okay, going back a few more, and then we'll finish. Okay, so one last question on the function stuff. Is there a timeout on DB functions?
There is a timeout in ADO.NET whenever you execute a query. So when
Yes.
Entity Framework goes to there and executes this, yeah, like if I was to put a thread delay that was bigger than that execute, I actually don't know what will happen. It will probably just block, honestly. I don't think it'll like cancel it or anything.
Yeah.
So no, there's really not, which is a good and a bad thing, right?
Yeah. Yeah.
Put your own timeouts in there when you're doing things.
I mean, again, with it being in process, it makes it a somewhat different model than ADO.NET is normally used to, where you're doing a kind of an out of process thing where it's more reasonable to, cancel it or whatever.
Yeah, what would happen is if you had a long-running function on one connection and another connection was trying to access that database, it would be locked. I'm pretty sure it would be locked. It depends, I guess, where it is, but it would time out. But the one actually executing the function, I don't think there's anything to cancel that inside of SQLite or ADO.NET.
Right. So we've talked a bit about reverse engineering. Any plans for a T4 editor, Brice?
Oh yeah, we found the T4 editor team, and we had a really cool meeting with them, and they were very excited about all this stuff. So that is, if you guys saw the T4, the templating community stand-up, I showed my editor, which was really really primitive. It basically just did coloring. But yeah, we are working with them to see what it would take to productize that and to make it built into Visual Studio. It is on their backlog. I'm happy to report today they're working on better .NET Core support, which is exciting. A lot of people are asking for that.
Yeah. So T4 coming back big time.
Love T4.
Okay, and then we'll finish with a couple of somewhat rude questions. The first one we're not going to actually answer. Will there be a rewrite of SQL Server? That's out of our domain. I don't know. Anyway, and then finally, Microsoft devs, EF Core or Dapper. If we could only use one for the rest of your career, what would it be?
Entity Framework.
Yeah, definitely EF Core. Sorry, Dapper. I love you, but spent 15 years working on EF. I'm not going to say I don't want to use it.
Yeah, and that's really what I was illustrating with my last thing. Like, I can write SQL, and if I'm writing SQL, I want to use Dapper. But I don't want to write SQL. I want something else to do it for me.
Yeah. Feel free to answer this if you want, Eric. We won't be offended, even if you say ADO.NET.
You're
You're
muted.
muted.
I was muted. I would have to confess that I've never used either one.
Right.
I'm sorry.
No problem.
Do you have an alternative? Do you use Fred Krueger's thing?
No, I'm one of those control freaks that unfortunately I tend to write my own layer, and but I never. One time I accidentally created an ORM. That was a sad day, but
It's usually how it starts.
yeah, no, it was awful. But yeah, no, if I was thinking the other day, if I started a new project on SQLite today, I likely would give everything a closer look. And I probably would look at MD SQLite with Dapper, but I don't know. I'd have to rethink everything.
Sounds good. Okay, well, I think that's about everything. We've done as we always do, and we're 26 minutes over. So we should just recognize this is an hour and a half and to be done with it. But anyway, thanks so much for being here, Eric. It was really cool seeing your stuff, and we really appreciate everything you do in the community and everything you do for .NET. It's really great to see. Always trying to work for Microsoft to be more supportive of that stuff, but it's a big company. It's a lot of politics, as you know.
Thank you.
Anyway,
my pleasure being here.
Yeah, and thanks, Brice, for sharing all this good stuff. And yeah, we've got one of these coming up on MySQL with Bradley Granger and Lawrence, who does the Pomelo provider. So I'm not sure if that's in 2 weeks or 4 weeks, but hopefully Shai will be back and by then as well. So we'll see you all for another one coming up soon. Thanks, everyone. Bye.
Bye.